Well, some 27 years ago, I was working in the Tumbarumba Batlow area in New South Wales, a well-known fruit growing area with orchards everywhere. I noticed at that time there was a lot of waste. There was waste left on the trees, there was waste on the ground, and there was waste in the processing facilities. I thought at that time I would be able to convert that waste into a poultry feed or a pig feed. Unfortunately, waste and materials like that weren't popular to have recycled at that time. 25 years later, recycling is a major issue and everyone is interested in recycling. So I was able to expand that original idea 27 years ago into recycling all food waste, taking food waste from hospitals, retirement villages, cafes, restaurants, hotels, everywhere where food waste is produced as a byproduct. In fact, 30% of all food that's produced is never consumed. So the idea is to take that waste and convert it into valuable products such as poultry feed and liquid fertiliser.
How do we turn food waste into food? A pilot facility has been designed to enable the development and fine-tuning of processing various food waste from different sources, such as hospital, educational, and restaurant food waste, fruit and vegetables, or higher protein sources such as meat byproducts.
Unless you're part of the solution, you are really part of the problem. And Food Recycle is a company that's going to provide a solution for Australia to overcome food waste problem and which can be applied globally.
Yeah, this particular project, we want to do a small laboratory scale trial before we do the large scale pilot trial. Collecting few different sources of waste material, we went through the whole process and determined the nutritional value to see whether we can incorporate those into a feed formulation. The process involves collecting the material from different sources, go through a heat treatment to make sure that we destroy all microorganisms, and drying the product in the most efficient way. And then we can grind the product and that become a source of feed ingredient, and we can mix into the different ratios depend on the final formulation we want.
The full-scale facility will include the key process steps in the pilot facility. The containers are modular in design. Depending on product characteristics, process steps can be interchanged.
So my initial skepticism fortunately has turned into optimism and enthusiasm, because I've seen the process in reality. I've seen the science going behind it, I've seen the engineering behind it, and I've seen the intelligence and the expertise that Norm's brought together to be able to bring this to fruition. I really think there is quite a significant opportunity for Food Recycle to become a relevant, valid part of the chicken feed industry.
A chicken needs about 50 different nutrients, and among those, about half of those would be trace elements and vitamins, and those are normally added as a vitamin mineral premix to the feed, so we don't really worry too much about those. The ones that we do worry about would be the energy content. Energy comes from carbohydrates and fat, and then the amino acids, which come from protein. Once we have the nutrient analyses completed of all the different waste streams, then we can take that information, put it into a formulation program, and blend them together to make an optimum poultry feed that may require additions of small amounts of other materials. And then we'll also be able to get an idea of the value of each of the different waste streams relative to the price of other ingredients in the marketplace.
Container 1 is the heat treatment step, comprising of a direct steam-injected screw conveyor. Killing the microbes is achieved via a combination of time and temperature. Steam is used in this case as microbes are more easily deactivated in wet conditions.
It's a matter of going to all the different state authorities, finding out what their requirements are and making sure the process covers off on all of those. I must say though that the various biosecurity authorities around the country, there's been a lot of goodwill. People all think that this is a good idea. Still need to do some contaminant monitoring, but we're well down the path to having all that covered.
RMR process, our business is set up specifically to design and build food manufacturing facilities. When the food recycle project came to us, we took a look at what they were trying to achieve and what outcomes they wanted from it. And we just thought it tied beautifully into our own business ethos of sustainability and building food safe, clean design processes, and particularly taking the food waste and converting it into something that's of high value and something that's meaningful and useful. So this project was a perfect fit for our company. Having a lot of years of experience in the pet food industry and pet food manufacturing, we found that could tie in, we could bring a lot of that knowledge, know-how, but also a lot of our networks, people that are experienced in all the different facets and areas of the process steps.
Scalability has always been an inherent focus within the process design. What that means is that the throughputs can be increased according to requirements so that the facility is future-proofed, but in a way that makes sense to economies of scale so that capital cost can be protected. So we've designed a full-scale facility that can process up to 3.5 tonnes an hour of food waste at the in-feed, with 3 main processing lines, each capable of processing a variety of food waste streams. The key is to look at the prospective locations of the facilities and to understand the volumes of waste and the types of waste that are being produced so that we can tailor a solution that makes sense to the location economically.
During my time in government, we looked to support projects that involved innovation, projects that were good for the environment, and projects that delivered economic benefits to our state. And certainly Food Recycle ticks all of those boxes. So it's great to be on the board of this company. I believe this company has enormous potential, not just for Australia, but globally.
Container 2 contains the maceration and dewatering step. Reducing particle size aids in increasing surface area for more efficient dehydration. It also aids heat penetration to the core of the particle.
When we were working on proof of concept studies to get chicken feed from food waste, we realized that there is a liquid extract which contained high concentrations of nitrogen, phosphorus and potassium. So we realized that this is the added benefit from the process, and we thought this could be a very good value as a fertilizer for plants because it has got all the essential nutrients which are needed for plants' growth. So we were working on proof of concept studies to bring the concentrations of all the nutrients in the liquid extract at par with commercial fertilizers. We are doing proof of concept studies to determine the value of this liquid fertilizer for growing hydroponics, lettuce, tomatoes and cucumber.
With the concept around value-adding waste, what's happened is we've been able to refine that waste stream, so we've been able to look at it at a more micro level. Historically, we've just collected all of this and we've called it waste and we've taken it off to the landfill. Now all of a sudden people are seeing value-add in parts of that waste stream, so that's allowed us to break the waste stream up, and to break that waste stream up we have to have multiple chambers in the vehicles and multiple bins to collect the different waste streams. We can also turn some of those waste streams that might have historically had a low value, all of a sudden value add them into something like extraction for energy, and then that leads us back to our circular economy and allows us to use waste to drive our vehicles.
Container 3 is the dehydration container. The pilot facility utilises a direct heat rotary drum dryer. Dehydration is important in that it ensures that the crumb generated is shelf stable by removing water activity. The heat applied during dehydration also serves as an additional microbial kill step.
So we predominantly use 3-on-6 grade stainless steel in the food industry. This is because of its corrosion resistance, its formability, so it is easy to fabricate, easy to weld, and easy to take that weld off to turn it back into a hygienic weld, if you like. We have a strong supply chain in Australia. It's cleanability, so once you've finished a product run for the day, it's very easy to clean the stainless steel and get it back into a hygienic situation ready for your next run. It's extensively used in Australia, so any food factory in Australia you'll find has got 316 grade stainless steel throughout, and it is very cost efficient. So when you do it once with stainless steel, you do it right and you'll never have to replace it. We use a steam injection for the biosecurity side of things to kill the bugs and bacteria to enable us to get to that hygienic point. So we've taken that steam from the carbon pipe through a hygienic filter, then after that process it's all run through stainless steel so that we can't get any impregnation of any contaminants once it's gone through that filter into the product. RMR Process come to us with a basic design of how they wanted the containers and all set up. We then forwarded that design on and actually made more improvements to make it easier in the long run for us to get these things fabricated, and even through the design of how the containers were set up. We had a lot of involvement in that to get this over the line, make it look good, make it functional, and at the end of the day I think the results speak for themselves.
Part of the food recycle process is that the waste needs to be collected daily from the waste providers. We needed to basically design a bin that was suitable for purpose to collect this waste, and part of that is ensuring that the waste produced by the producer doesn't get tampered with or added to between when they put it out on the curb and when it gets collected by the vehicles. What we ended up with was a double-lidded system that effectively allows the waste provider to lock and unlock and uses a secondary lock for the waste collection vehicle to collect the waste, meaning that it's tamper-proof from any external sources.
Container 4 is accumulation and blending. Here, the dehydrated crumb is passed through a hammer mill and then stored as a shelf-stable fine powder. When the material is ready for blending, the correct proportions of powder waste can be collected according to a feed recipe. The ribbon blender ensures a homogeneous mix. Minor ingredients can also be added at this point to enhance desired nutritional content and to meet the poultry formula feed requirements.
Once we blend all the streams together, we will be able to determine what could be deficient, but that's not a problem. We can blend those in to optimize the feed. Part of the process to the final blending of these streams will be the pelleting process. And the pilot plant has a commercial pellet mill that forms the material into a pellet, and most all meat chicken feeds are fed a pelleted diet. Pelleting, the quality of the pellets are very important because that's a main factor in palatability. So palatability is a factor in palatability. And chickens don't have that many taste buds, but they're really after the texture of the feed. So if they can grab a pellet, swallow it, they're happy.
Container 5 is the pelletization container. The blended mix can now be fed into the pelletizer to produce the final product after an additional drying step for shelf stability. Food waste that would have previously gone to landfill has now been repurposed and transformed into value-added product.
For me, food recycle, it's very hard to see where the limits are. Actually, today we've seen it's all about collaboration, and we've had some very interesting and challenging questions on scope and size and where we think food might go, but we're just open. We think what we have is a global company potentially with reach across a lot of different industries, such as biosecurity, water recycling, water retention, those sort of things.
This is a global problem. There's food waste everywhere and there's chickens everywhere. So our licensing model allows us to deliver quickly this type of facility globally. Any town with a population of 10, 12 or 15,000 people is capable of having a small facility converting all their food waste into poultry feed and then moving it on to the poultry farms that are generally in their area anyway. The only model that is capable of spreading this out quickly to thousands of locations across the globe and hundreds of locations in Australia is the licensing model that Food Recycle Limited is offering. That license gives those people the opportunity to use the technology for 20 years. We supply the machinery and the equipment under that license so that we know that the standard for all the poultry feed is going to be maintained through the manufacturing process. We have to ask ourselves the question, where are we going to get the feed to feed the animals that feed us? So we have to get smarter about it. If we collected all the food waste in the world, we couldn't produce enough poultry feed, but we can make a big dent in what's required to come off farmland. We can probably produce 30 to 40% of all the food that's needed for poultry and pigs if we get smart about it and collect that food.